Okay, so this is Unit 2 review. We're going to do numbers 15, 16, and probably I'll just cram in 17 too, because that's the last one. All right, so let's take a look. The given is 2 and 3 are supplementary, and no given is filled in here, so I'm just going to assume that that goes right here. 2 and 3 are supplementary. Typically, you start with the given. You don't have to, but it's a good rule of thumb. Okay. The next step says definition of supplementary. Well, hopefully by now you're learning if you have supplementary angles, the definition says make them add up to 180. So M2 plus M3 equals 180. Okay. The next line says M1 plus M2 equals 180. If you look at the picture, here's M1, here's M2. They're right next to each other. So anytime you add two angles next to each other to get the big angle, that is called the angle addition postulate. So let's go ahead and put angle addition postulate. Okay, now the next line says substitution. And if you look at the lines before it, because that's where the substitution has to come from, I got two things that both equal 180. So instead of writing 180 here, I'm going to plug in 2 plus 3 for it instead. So this next line will be 1 plus 2. And then instead of the 280, I'm going to write 2 plus 3. Okay. Now the next step says reflexive. And then you might notice in the line after it, it says M1 equals M3. Somehow I have to get from this line 4 to that line 6 using a reflexive step. And you hopefully notice that there's an M2 on both sides of the equation in step 4. So that's the reflexive part. And then in order to get to step 6, I'm going to subtract straight down. And I'm left with M1 equals M3 subtraction. Okay, so at this point we know this angle, 1, and this angle, 3, are the same. In the next line, it says M3 equals M4. Well, if you look, or 3 is congruent to 4. If you look at the picture, that should be clear because they're vertical angles. So this is vertical angles are congruent. And then we have to prove the final thing. 1 is congruent to 4 or M1. Oh, what's wrong with the pen? M angle 1 equals M angle 4. Sorry. There we go. So that's going to go down here. M angle 1 equals M angle 4. And if you think about it, well, 1 equaled 3, 3 equaled 4. So anywhere that a 3 appears, I could replace it with a 4. That'd be substitution. Or, if you remember the rule, if A equals B and B equals C, then A equals C. That's called transitive, the transitive property. Okay. Let's try 16. So in 16, we've got some complementary angles here. A couple pairs listed right off the bat, these two. 1 and 2 are complementary, 3 and 4 are complementary. Okay, so this is going to be given. Notice we didn't use all the givens. Down here in step 4, here's the other given. AC bisects angle BAD. All right. So step 2 is blank. Now that means it probably comes out of step 1. And if you have complementary angles, we know that they should add up to 90. So M1 plus M2 equals 90. And also, in the same way, M3 plus M4 equals 90. So hopefully you're remembering that if you have complementary angles, then they add up to 90 is the definition of complementary angles. Okay, the next line says substitution. And I'm hoping by now you're starting to recognize when two things equal the same amount, you can substitute in one term for the other, just like that. So then this line would be M1 plus M2 equals, and then instead of the 90 up here, I'm going to replace it with the 3 plus 4. Okay, step 4 is AC, this thing, bisects BAD, the big angle on top. So if that's a bisector, we know that these two angles should be the same. And that's what the next line says, M1 equals M3. So I have a bisector and I get two little angles that are the same. So remember the one that says if you have a bisector, then you get two equal small angles. That's the definition of angle bisector. The theorem, the angle bisector theorem, is the one that says you have a bisector, so one angle is half of the whole angle instead. So that's different. Oops. Okay, so let's see. We have to end with measurement of 2 equals measurement of 4, or 2 is congruent to 4. But notice we used all these m versions up there, so I'm going to write m2 equals m4. This one's a little bit harder to see. So I'm going to rewrite a couple of steps on the side here. Here's step 3, m1 plus m2 equals m3 plus m4. And then I'm going to write step 5 right below it here, m1 equals m3. And then notice step 6 is m2 equals m4, measurement of 4. So if you look at this, you might notice, oh, if you subtract these lines right down, you get 2 equals 4. That's line 3 minus line 5, gives you line 6. Oh, whoops. Let me write subtraction first. And now it's line 3 minus line 5 gives us line 6. Okay. Let's try 17. So 17, there's going to be a bunch of ways of doing this. I'll just do one. I have not prepped this ahead of time, so we'll see what we come up with. So I think in the key that I provided for you guys with, I gave you a couple different ways of doing it. So let's see. M1 equals M2, and the goal is to prove that 3 and 4 are the same. Now, I'm not going to give you a proof from scratch on the test, but if you can do this, then you're probably in pretty good shape. So let's see. Let's start with the given. M1 equals M2. Given. Okay, so somehow we have to involve the 3 and the 4. So I do know that 1 plus 3 has to be 180. That's pretty much the only equation I know I can come up with involving the 3. So 1 plus 3 equals 180. And then over on this side, I can do the same sort of thing. 2 plus 4 has to be 180. So I'll just put that in the same step here, because they're really the same reason. I'm adding two angles next to each other to get the big angle. So that's angle addition postulate. Okay, well, we've done a lot of the proofs now where if two things are both 180, then the two things are equal to each other. So this thing and this thing should be equal. I'm just going to plug that in for the 180 right there. So I'm going to say M1 plus M3 equals M2 plus M4. And that's substitution. All right, we're replacing the 180 with something else that's equal to it. Okay, so I'll tell you now, we can actually finish the proof. I think the hard part is the way that we've organized it. So what I'm going to do is I'm actually going to take this step right here and move it. If I can. Let me try that again. To here. Okay, and then I'm going to move this part over a little bit too. There. Okay, now you might notice if I subtract straight down, these guys cancel, and I'm left with 3 equals 4. Measurement of 3 equals measurement of 4. And that's because of subtraction. And that's line 3 minus line 1 equals line 4. Now, you don't actually have to move that line. That can still stay way up here if you want it. It's just a little bit harder to see that subtraction step, I think. And then that's it. That's all there is to it. Okay, I hope that helps a little bit, and good luck prepping for the test.